Welcome to this video lecture. Myself Atul Kumar, working as an assistant professor in Department of Computer Science, Rajiv Gandhi Memorial, Government College, Jogindarnagar. This video lecture is about stacks. So the contents of this video lecture: firstly, introduction to stack, operations on the stack, and how the stacks are represented in the memory. So what is a stack? Stack is a linear data structure of variable size. So in case of array, array is basically a homogeneous collection of elements. We can insert or delete the element at any place, but in case of stack we can these operations are performed only at one end, that is known as top. So there is only one end in the stack, that is a top, and from the top we can insert or delete the elements. So the insertion in stack is known as push operation, and the deletion in stack is known as pop operation. Stack is also known as last in first out, means the element that is added in the stack, last element that is added in the stack will be the first element to be removed from the stack. So I will discuss this with the help of example. Suppose we have a stack and it has elements 10, 20, 30, 40. Suppose we want to insert a new element 50 in the stack. So this new element is added here. So I am adding here 50 element, and the top now is incremented or start pointing to this position. So top is incremented by 1 from this position to the next position, and this one is the element that is added. So in the previous slide we have discussed stack is also known as last in first out. So here the last element is added here is 50. So if we want to apply a pop operation here, so when we apply a pop operation, so it will delete the lastly element added, and the lastly added element here is 50, so popped item is 50. So this is the basic illustration of last in first out. There now there are two kind of operations on stack. One is push operation and other is pop operation. What is a push operation? Push operation is basically the insertion of new item or element into the stack. The elements are inserted at the top of the stack. We can perform the push operation only when stack is not full. If the stack is full, then the condition is known as overflow condition. In that case, we can't insert a new item or element in the stack. So this one is the illustration or example of a push operation. Firstly, we have a empty stack and we have pushed an item 2 in the stack, and now the top is start pointing to this position, and in the second step we have pushed the item 3. The top pointer is start pointing to this position. Then in the third step we have pushed a item 4, and now top is start pointing to this position. Next, in the next step, fourth step, we have pushed an item 5. Now the top start pointing to this position 5. In the next step we have pushed an item 6. Now the top start pointing to this position 6. Now we can see here At the starting point, the size of this stack here is 5. 1 2 3 4 5. So we can add maximum of 5 elements in this stack. Now at this position, suppose we want to push another item 6 or element 6 in the stack. So in this case, our stack is already full, and if the stack is already full, then this condition is known as overflow condition. So what is overflow condition? The overflow condition is that we want to insert a new item, or we want to push a new item in the stack, and the stack is already full, then the condition is known as overflow condition. The next operation we have in stack is pop operation. So pop means to delete the item or element from the top of the stack. So we can perform pop operation only when stack is not empty. So if the stack is empty and we are going to perform a pop operation from the stack, then that condition is known as underflow condition. So suppose the same scenario we have a stack and it is already full, and if we want to delete a new or pop operation, so firstly 6 is popped or deleted from the stack, and now the top is pointing to this position, and if we apply this pop operation, then the top is decremented by 1 and it start pointing to the position where the element 5 is there in the stack. Then after popping one more item from the stack, that top start pointing to this, top is decremented by 1 and it start pointing to this fourth element 4. After one more pop operation, the top is decremented by 1 and start pointing to this element 3. When we apply one more pop operation, then the top is pointing to this element 2. When we apply one more pop operation, then this 2 element is deleted, and in that case top the value of top is equal to -1 if we are just implementing the stack with the help of array. Now how we represent the stack in the memory? So there are two different representations of stack in the memory. One representation is by using array and another representation is by using linked list. So firstly, how do we represent stack with the help of array? So we all know array is the homogeneous collection of elements. So elements are added in the array, only homogeneous elements are added in the array, and we have to specify the upper bound and the lower bound, because in case of array we have two bound, one is upper bound and other is lower bound, and upper bound specify the size of the array. So how basically upper bound is to represent how many total maximum size of the stack, or how many maximum elements we can just enter in our, or we have to just insert in our stack. So in case of array representation, we have only as I have mentioned earlier, there is only one pointer, that is top, and this top is used to hold the index of stack topmost element. And when the stack our array is empty, then, or the stack is empty, then in that case the value of top is -1. Sorry, this one is -1. And when we start adding or pushing the value in the array or stack, the value of top is incremented by 1, and if we want to delete the element from the stack, then this value is decremented. The value of the top is decremented by 1. Max is the maximum size of the stack. It represents the maximum size of the stack. So here firstly I will discuss the algorithm for push operation, so in with the help of array. So there are 4 steps in this algorithm. The first step is if top is max, that is the stack is already full, then in that case we have to print stack is full, and the condition is known as overflow condition, and the algorithm exit from here. If that condition, the step 1 condition is not true, that is top is not equal to max, then in that case we have to go to step 2, and we have to firstly increment the value of top with 1, that is top is equal to top plus 1, and in the third step we have to just enter the or assign the value of that assign the value to this s top, and after that step 4 is the exit from this algorithm. So I am just explaining this algorithm with the help of example here. Suppose we have a array or a stack having 4 elements. Firstly, stack is empty, so the value of top is minus 1. Now suppose the name of the stack is s. So we all know the index of array start from 0, so this one is 0, then this one is 1, second and third. So first element we want to push in the stack. So firstly we have to check whether top is equal to max. Here the max is equal to size of stack is 4 minus 1 if the index start from 0. Here top is not equal to max, as top is equal to minus 1. So we go to the step 2. In step 2 we have top is equal to top plus 1. So the value of top now minus 1 plus 1, that is the value of top is 0. Now in the third step we have to assign the value of top is 0, s0 we have to assign, and suppose we want to insert 35 here. So we assigned a value 35 at the position s0. Now 35 is inserted here, and top start pointing to this position. So suppose now we want to push one more item, and the item is 10. Again the same algorithm will be followed, and in this firstly the value of top is checked, so this condition is false. Then we go to the step 2, and in step 2 top is equal to top plus 1. The value of top here is 0. The value of top now becomes 0 plus 1 is 1. Now s of 1 is equal to the value we want to push, and that is 10. So 10 is assigned to the position 1. So here the 10 is added, and now the top start pointing to this position. In this way we can apply a push operation with the help of array. Next operation we want is pop operation to delete the element from the stack with the help of array. So here the algorithm looks like this. In the first step we have, if top is equal to null, then we have to print stack is empty and the condition is underflow. In the step 2, firstly any value that is on the position that is top is pointing, we have to assign this value to the variable data, and in the third step we have decremented top to top minus 1, and then fourth step is exit. So to understand this, suppose we have an array or stack having 4 items, 35, 20, 15. Suppose this one is the scenario, and the top is pointing to this second position, that is 0, 1, 2 and 3. Now how can we implement this algorithm? Firstly we have to check if top is null, so this condition is false. Go to step 2. In the step 2, s of top, now top is at position 2, s of 2, we assign the value that is on the second index to the data. So data is equal to the value at index 2 is 15. So in data we have assigned a value 15, then we decrement the value of top. Now top is 2, the top becomes 1. Now top start pointing to this position, and this 15 is deleted from the stack. In this way we can apply a pop operation on to the stack. The next representation of stack is with the help of linked list. We all know linked list is a linear kind of data structure, and we can also implement stack with the help of linked list. So it will be helpful to eliminate the drawbacks of implementation of stacks using array, because in case of an array we have to check in advance about the size of the stack. But if we implement with the help of linked list, so this limitation can be removed from this. So firstly this one is the algorithm for insertion of or push operation in the stack with the help of linked list. Firstly we have to check if the space is available in the memory. If there is no free node is available in the memory, so we have to print free space not available and the condition overflow. Then we have just if there are many nodes available in this free space, we have to just create a new node, and from this free space nodes, and the name of this new node is new. And in the third step, first we all know in the linked list each node has two parts. The first part is the information and the second part is the address that pointing to the next node in the linked list. So in the third step we have new is equal to info implies data or info pointing data. So we just in the third step we have added any data we want to insert in the stack. Suppose we want 35 to add in this node, so this 35 is added in this new node. And the next uh, instruction is new next is equal to top. New next is equal to top. New next is equal to top means, firstly the linked list is empty, so top is null. So this one is the scenario. So if top is null, so the new next means the next node pointing is top, and top is already null, so here is null. We add here is null. The fourth step is top is equal to new. Now the top start pointing to this new node. So in this case, in this way, we can insert a, or we can push a new node in the stack. So suppose we want to add one more node. So this one is the scenario here. Again, one new node is created firstly from the available free space of nodes, and then information is added. Suppose we have added information or element is 15, and new next is top. Now top is pointing to this new node, so new next is top means it start pointing to this. That is because the address in the top, we have a address of this new node. Now this address is inserted in this new node, so it start pointing to this new node. And in the next step, top is equal to new, and now the top start pointing to this new node. In this way we can add or push the nodes within the stack with the help of linked list. The next operation we have is the pop operation, and we have to implement this pop operation with the help of linked list. So the algorithm looks like this. If top is null, this means stack is empty and the condition is underflow. In the next step we have to check if top is not null, then firstly we have the information or element, we have to insert or assign this element to the variable known as data, and we have one more temporary variable that stores the address of the top. In the next step we have to just increment the top to the next node, and then we have to free that node and exit from the algorithm. So in this case, in this way we can insert or delete the items from the stack with the help of linked list. So this is all about this video lecture about stacks. Thanks for watching this video lecture.